Welcome to our podcast, where we explore fascinating stories and ideas from various fields. In this episode, we will talk about the nuclear clock revolution and how it will change timekeeping forever. The first nuclear clock of the world is likely to start ticking soon after scientists at the GILA, a joint institute of the University of Colorado Boulder, and the National Institute of Standards and Technology, successfully cracked the workings of all the components required to construct one. An atomic clock uses vibrations created from an atom to measure time, and on the other hand, signals from the nucleus of an atom are used for timekeeping by a nuclear clock. Currently, the most precise method for measuring time is in atomic clocks. These clocks coordinate international time zones and help in synchronizing financial and internet transactions. In day-to-day life, the precision of an atomic clock may not play a role, but it is used for things like GPS, digital communication, and internet speeds. The nuclear clock is expected to measure time with much higher precision by using the energy jumps from the core of an atom. The nuclear clock's energy level is closely coupled to strong forces in the nucleus, while atomic clocks mainly depend on electromagnetic forces, said Chuankun Zhang, a physicist at GILA, while speaking to Interesting Engineering. Thus, a nuclear atomic clock comparison can provide sensitive tests for fundamental physics, he added. The nuclear clock has not been assembled yet by the researchers, but they have gathered all the components that are required to construct it. We managed to improve the accuracy of this measurement by 1,000,000 times compared to previous measurements, said Zhang. This allows us to resolve the quantum energy sublevels of this nuclear transition for the first time, he added. Speaking about when the clock will be ready, he said, "We are working on improving the spectroscopy resolution further and evaluating systematic shifts of the transition so we can get better clock accuracy when we start operating it as a clock. Essentially, we have all the parts for a nuclear clock already demonstrated in the lab. We have not used them for the actual clock operation, but there's no technical difficulty in building one any day now," he added. "We can probe the nuclear transition in a solid-state system, which would allow us to build a much simpler clock than today's atomic clocks, without needing technologies like an ultra-high vacuum, laser cooling and trapping, etc., Zhang said. Thanks for tuning into this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.